Simple question.
Okay.
How is autism, or rather acetaminophen, linked to the onset of autism on a molecular level, pathophysiological level?
What happens with that drug is that there's two safe pathways that it can go down, and you see them there, glucuronidation and sulfation. So when Steve Schultz first figured out, wow, there's this huge association with autism and regressive autism and acetaminophen, in the literature at that time, it was already known, it's known since 1999, that children with autism can't do that top pathway, sulfation. A lot, especially with severe autism, they tend to be very impaired with sulfation pathway, which, by the way, also makes them impaired with that other the other green pathway down at the bottom, the glutathione pathway, and that's related to vitamin B9 metabolism. So we can go into that later if you want. It's not my specialty, but it's not. This is not rocket science. This is basic metabolism that's been worked out for decades. And this is the other amazing thing, that you see that pathway, glucuronidation. Now, the green arrows indicate sort of safe ways to get processed for your body to process acetaminophen. But that other green arrow, glucuronidation, that one is not functional during the first weeks of life. And it's not very functional in the first weeks of life, right when you clamp the umbilical cord. Now, pregnant mothers...
And I'm sorry to interrupt. That's whether you have ASD or not, just in general, the human...
Right. So everybody has increased susceptibility in the first weeks of life. Everybody does. And this was already known prior to 2008 when Stephen Schultz found everything I'm showing you. So this pathway, I didn't invent anything here. Everybody knows this. This is worked out in the 1950s and 60s, literally. And then people were figuring out, wow, people with autism, they really are having, children can't process things via the glucuronidation pathway. And so what that leaves you with is that red pathway there, which is called a quinoamine. It's NAPQI. You'll see it a lot. N-acetylparaquinoamine. It's super, super toxic. It basically acts like mercury and sticks onto, it likes mitochondrial proteins for some reason, and it tends to destroy mitochondria, which will cause the cell to do what's called, and your listeners probably know about apoptosis. That's what it'll,
programmed cell death.
Yeah, programmed cell death.